We're on Chapter 8, Lesson 4, Multiple Representations of Functions. Please turn with me to page 603. So, again, multiple representations of functions. What are we going to learn? We're going to learn how to graph and use tables. So we're learning the same thing. So understand that a function is an equation. An equation for us is y equals some rule and x. Okay, let's look at the real world example. I have a guest speaker with me today. Ian, take it away.
A group of friends are going to the museum. Each friend must pay an admission price of $9. If one friend is going, the total cost is $9. If two friends are going, the total cost is $18. If three friends are going, the total cost is $27. And if four friends are going, the total cost is $36.
That's awesome. Now graph it. Let's get it. Remember, when we graph, we have to be on the line. So 1, follow it up to 9, put a dot. Great. When you put a dot, let's make the dot just a little bit bigger. 2 is at 18, so go up 2 to about 18. Put a big dot. 3 is 27. 4 is 36. Connect your dot starting at 0, 0, and off it goes. So, Ian, what does this look like? A
Bar graph.
A bar graph would have bars. This would be a
Linear graph.
A linear graph because it forms a
Line.
Very good. So put linear. It's the word line with an AR at the end. Awesome. Now, we got to write an equation. So we have to start with y equals. Please put y equals. And what was your multiplier again?
9.
9. And then we're going to use the letter x. High five, Ian. Great job. Thank you for showing up. Okay, just to wrap up the first page, question number 4, list the ordered pair if 5 friends go. 5 friends go. 5 times 9 is 45, so it would be 5 comma 45. Put it in parentheses. Turn the page. Alright, so now we're going to represent functions using words and equations. A runner's distance in a marathon is equal to 8 miles per hour. Distance is equal to 8 per hour. Equal to 8. I don't know why they used a T. I would use an H for hour. Alright, so words and equations can be used to describe functions. For example, when a rate is expressed in words, it can be written as an equation with variables. When you write an equation, determine what the variable is by reading it. Okay, let's look at number 1. The drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation for the total amount. So, T is good. T equals 5 times P. Notice that they spoke it as T equals 5 times P, but then when they wrote it, the dot did not show up. Why? Because the invisible operation is multiplication, and we do not show the dot because we show coefficient variable. So it's T equals 5P. 5 is the coefficient, P is the variable. In a science report, Mia finds that the average adult breathes 14 times each minute when not active. Write an equation to find the total breath of a non-active person takes in m minutes. So again, they've told us what we're looking at, 14 times, so we know it's going to be 14 times each minute, and we want it with breaths. But we can't put the dot, so we would write that as D equals 14m. Alright, now it's your turn. Okay, that was funny. Okay, so for number 1, the mouse travels at 8 miles per hour. What is the distance? So it's D equals 8h, and the next one is 36 cookies. She makes 36 cookies per hour. So how many cookies? So that's cookies equals 36 times h, or 36h. Turn the page. Okay, so we're going to represent functions using tables and graphs. And again, we always use tables and graphs because pictures speak 1,000 words, and it's easier to represent this. Now let's look back at this. Remember I told you this is the same thing, although they're using different things. This will always be your input, which is X, this is your Y, but we're using letters representing what they're talking about. So the change in Y is 8, so we know that this function right off the bat is 8, and we're going to use what they're using. So 8x equals m for mile. We can't put mi because that's 2 letters, but we could put a little I if we wanted to. That's not very little, is it? Let's make that really little. We can make that a subscript. So we have our m and our little I. We could also use a d for distance. And then when we graph it, notice that it's the linear function starting at the origin. Okay, let's look at these examples 3 and 4. The student council is holding a car wash to raise money. They charge $7 for each car that they wash. So 7C, that's our algebraic expression. It doesn't become an equation until we make it equal to something, and it's total earned, which is T for total earned, and 7 for each car. So 7C equals T. And again, we write our equation, and then we graph our ordered pair. When we graph our ordered pair, 1 is to 7, 2 is 14, 3 is 21, 4 is 28. We make a line. It is a linear function. Turn the page.
Where pause the video!
Alright, so we have an eagle flying 30 miles per hour, so our function equation would be d equals 30h. When we graph it, we find out that it's linear because for 1 hour it's 30, 260, 390. We graph it, it forms a line. We have a linear equation. Now it's your turn. Please do the guided practice. Come back when you're done.
Get it, got it, go! Pause the video! Get it, got it, go!
Okay, so the first one, we have lunches costing 3 per lunch. So the total is T equals 3N. Then I fill out the table. For 1 lunch is $3, 2 is 6, 3 is 9. I graph it, I get a linear function. So in number 2, why do you represent functions in different ways? Well, you use tables to solve, but you use graphs to see the pattern. We use graphs all the time to interpret and analyze our data. All right, class.
Bye.